Today we are going to learn about the basics of recursion and how to trace code recursively. First of all, when you talk about recursion, you want to discuss how we stop. The act of recursion is doing the same thing over and over, but with a simpler scenario. A common example I like to have people think about is washing dishes. So for example, if you have a sink full of dishes and somebody says, "How do you know when you're done?" Well, the simple answer is when the sink is empty. So you look in the sink, and if the number of dishes is 0, then you're done. If there aren't, then you wash a dish, and now you continue the process with one less dish to wash. And you'll notice that when you are doing this code here, you are actually calling the same method over and over. So if I were to start the process with, say, 5 dishes in my sink, I would go and look in the sink and say, do I have 0 dishes? No. Okay, wash a dish. Now I'm going to wash dishes with 4 dishes. Do I have no dishes left? Nope. Wash a dish. Now I do it again with 3. And we keep on doing this until we get down to where we try to wash a dish and there is none left. And then we have reached what is called our base case. And our base case is our stopping point. We always want to check this stopping point first, because if our stopping point has been met, then we don't want to continue recursively calling our method over and over. If we were to do that, we would get into infinite recursion. So as I just mentioned, we always check our base case first. This is how we're going to end our recursive process. If the base case isn't true, then the next call will be the same recursive method again with a simpler problem to solve. Typically, it is 1 less or 2 less than what we started with, or it is a smaller string. We are always going to keep making that issue or that problem a smaller and smaller subset until we have reached the smallest set of them all, or the base case. Many simple recursive problems can be computed as loops. And a lot of times when students are first learning about recursion, they will say, well, I could have done that with a loop. Why did you do that? Well, we start out with the simple problems to help you understand how to code trace. Then, once you get to the harder recursive problems, at that point the loops are no longer efficient. We also want to be very careful about infinite recursion. When you have infinite recursion, this is when what happens is you end up getting a stack fault. And the compiler and the computer are the computer is going through and is calling more and more and more and more methods. Now, essentially what's happening when we are making these recursive calls is we are having the computer kind of go on pause while we make the next method call. And then it goes on pause and we make it the next method call. And it is stacking up all of these method calls that we have to come back to. And eventually, if you stack up too many calls, it's going to get overloaded. And that's actually where the term Stack Overflow was probably coined from. So infinite recursion is a really common problem that people get when they're writing recursion. All right, so let's take a look at how to trace recursively. So in this first problem, we are going to call it fun. And our first scenario is our base case. You always want to make sure that you are able to recognize where your base case is so that you know when it's been met. If we haven't met base case, then we are going to do a certain action and then we will call our method again. Now, what I typically do when I'm tracing my code is whatever the method is called, I typically just write the method call with the first letter. So in this case, we are trying to do fun with an input of 8. So when I start off, I'm going to say fun of 8. And I ask myself, is 8 less than 1? No, it's not. Okay. So then what I'm going to do is I'm going to print out x divided by 2 plus 1. So in this case, x is my input. So I'm going to do x divided by 2, or 4. 4 plus 1 is 5. So I'm going to print 5. And then after that, I'm going to make another method call. And now I'm going to call fun with 1 less. So I'm going to call fun of 7. And off to the side here, I'm going to keep track of the values that I'm printing. Now I'm going to do this again. Is 7 less than 1? No, it's not. Okay. So the first thing that I'm going to do is print 7 divided by 2 is 3. 3 plus 1 gives me 4. So I'm going to print 4. Let's write down 4. And then I'm going to recursively call fun of 6. Is 6 less than 1? No, it is not. Okay. So I'm going to print out 6 divided by 2, which is 3, plus 1, which is 4. So I'm printing 4. Now I'm going to call fun of 5. You'll notice as we're going through, my input keeps getting smaller and smaller. Now we want to make sure we're keeping track of what function I'm on as I'm printing, as I'm going through. It really is a process you need to be writing down. You do not want to be doing all this in your head. All right, so I get to fun of 5. Again, 5 is not less than 1, so I'm going to continue on. 5 divided by 2 is 2. 2 plus 1 is 3. I'm going to print 3. Print fun of 4. 4 divided by 2 is 2, plus 1 is 3. I'm going to print 3. Fun of 3, and we just keep on going here. 3 divided by 2 is 1, plus 1 is 2, so I'm printing 2. Fun of 2, we can tell we're getting close. 2 divided by 2 is 1. 1 plus 2 is 2, so I'm going to print 2. Now I'm going to call fun of 1. Is 1 less than 1? No, it's not, so I still keep on going. 1 divided by 2 is 0. 0 plus 1 is 1, so I'm going to print 1. Then I'm going to call fun of 0. We have finally reached base case. Dun 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 dun. All right, so now let's look at base case. I'm supposed to print x divided by 2, so 0 divided by 2 is 0. And so my final answer is 544332220 or 10. All right, now our next problem that we're going to do doesn't have quite so many tracing steps. Some problems will have a lot of tracing steps, other ones won't have quite so many. Let's go to problem number 5. So here, you'll notice that our base case is going to stop a little bit sooner. You'll also notice that we have 2 inputs. We have an X and a Y. And this one is called more fun, so I'm going to just call this M. And I'm going to say M of 6 and 5. So 6 and 5. And then to help me out with not confusing which one is which, this is my X value, and this is, oh, that doesn't show up very well. This is my X, and this is my Y. Okay, so is y less than or equal to 2? No, it's not. So then what I want to do is I want to return more fun. I want to keep my x value the same, so it's going to stay as 6. And then I'm going to do y minus 2. So 5 minus 2 is 3. And then I want to add on the value of y. So for this method call, the one that I was just on, the value of y is 5. So you don't want to get confused and use this value of y. No, no, no. We want to consider the current method call that I'm on. All right, so now I keep going, and I ask myself, is 3 my y value? Remember, we have x and y. Is 3 less than or equal to 2? No, it's not. So I'm going to call my method again. So more fun, x value stays the same. My y value decreases by 2. So again, I am taking this y value of 3. So 3 minus 2 is 1. And I'm going to add this y value, which is 3. And now I try calling it again. Is y less than or equal to 2? Yes, it is. Woohoo! We have reached base case. So since we have reached base case, now what we do is we return the y value. So we just return 1. Now at this point, what we're going to do is we are going to start backfilling the values to get the final answer. So I'm going to go ahead and I'll say, all right, I'm going to take this value of 1 and I'm going to put it right here. And 1 plus 3 equals 4. And then I take this value of 4, and since all of this is what 4 equals, I put 4 right here. And 4 plus 5 equals 9, and that is what all of this is equal to. So that is my answer. So this is equal to 9. All right, I want you to pause the video and try the next one on your own. I'm going to write out the work for it, and but I'm not going to explain it just because of the time that we're on, but I want you to try the next one on your own, and if you can't figure it out, I can help you with it the next day in class. Just joking, I forgot. All right, I forgot that I wanted to try to get one more problem in this video. So this one here, the answer is 24. Here is the work for it. All right, let's go on to this problem here. Now, what we see going on here, this one's a little bit different from some previous ones we saw. You'll notice that we have a recursive call and then we have a print statement. So as these recursive calls stack up, essentially the code gets put on pause. And that print statement doesn't happen until we come back. So let me show you what this looks like. I start out with mystery of 32. So I'm going to say mystery of 32. And I check, is 32 less than or equal to 1? No, it's not. So then I'm going to call mystery of 16. Now, you might be wondering, well, what about this line of code? Well, this guy's got to wait. So I'm going to come back and I'm going to say, okay, I need to call, is 16 less than or equal to 1? No, it's not. So I'm going to call it again. 16 divided by 2 is 8. So I call mystery of 8. Again, this is put on pause. So each one of these has another line of code that needs to be executed. They're all waiting. You can think of it like this. They're waiting to be ran, but they haven't been run yet. So we're going to come back to them. All right, so then I check, is 8 less than or equal to 1? No, it's not. Divide by 2, is 4 less than or equal to 1? No, it's not. Divide by 2, is 2 less than or equal to 1? No, it's not. Divide by 2, I get to 1. Is 1 less than or equal to 1? Yes, it is. Hallelujah. Okay, so since it is, what I'm going to do is I'm going to print out my value of n. So here's what happens. I print out n, which is 1. So if I look at what's printed, I print a 1. And now this task is done, and I return back to where I came from. And when my input was 2, I still had this line of code left to do. So now I'm going to print off the 2, and now that job is done. And then I return back to where I left, and this method call still has to do a print. So I'm going to print a 4, and then that pops off. And then I return back to the 8. And this guy still has to print. So I print an 8. And now that job is done. And I return back to the 16. And when I had m of 16, I still had to print. So I print my 16. And now that job is done. And I come back here, and I still had to print my 32. And now that job is done. And now I am completely finished with my recursion. Now, recursive tracing is one of those things that once you get the hang of it, it seems so much easier. But until you get there, it is definitely tricky to understand. All right, I'm going to stop the video here, and I'm going to go through the last 3 examples in another video. I strongly encourage you to watch them today if you are able to.